Hi everyone and welcome back to my channel. For those of you that are new here, my name is Ellie and I'm the founder of Code of the Future. And today we are going to be continuing with the Rust course. So as usual, I'm going to put my glasses on and I'll move you onto the screen. Okay, so in the previous section we touched upon variables and I mentioned some things called, U32s, I32s, just briefly mention data types. Now, if you were slightly confused in that video, don't worry too much because I will be explaining everything in this video. And we are now in tutorial 6, so section 6 of this series, and we're going to be learning about data types. Okay, so I'll just cross off this and we'll open up the tutorial 6 main file. Let me find it. There we go. Yep, hello world. Just checked that it was all working okay, and it is. Cool. Now, checking back to data types, kind of the section on the Rust programming language document, it goes through a lot of stuff in here, in detail, and I'm hoping to cover everything that's on here through a video rather than in words. But if you are, left with a bit more kind of, thirst for more, I guess is the saying, then definitely check out this page. There's a whole range of different things, but I'm hoping to go through everything in here. Now, the first thing that I'll say is data types, because that's exactly what we're going to be doing here. Now, data types is just essentially what kind of type the data is. That's kind of as simple as I can put it. A variable, like an integer, is an integer. A float is a float. So decimal, if you're not aware of what a float is, it just means a number with a decimal after it. You've got Booleans, which are true or false. You've got a whole range of different data types, string, all sorts. And this video is going to be going into the main data types. Now, before I start, I just want to say that we'll be looking at primitive data types. And these are kind of the fundamental ones, I guess. So just as a bit of a summary. Now, if we go back on the documentation, you'll notice that there are two different types of data types. There are two categories. Two different types of data types sounds a bit. It doesn't kind of sound quite that right. So two different categories. We have scalar types. Oh, just gone back. We have scalar types. There we are. And we also have compound types here. So in summary, we'll just start by saying here there are two categories, I don't know if I spelled that right, of data types. We have scalar. Now scalar, and I'll just read this off the webpage. Let me find scalar. A scalar type represents a single value. Rust has 4 primary scalar types: integers, floating point numbers, Booleans, and characters. You may recognise these from other programming languages, and we're going to be looking at how they work in Rust. So I'm just going to copy this and we're just going to put it onto the file here, just so that when you are coding and you're checking back on your files, you can see this and be like, oh yeah, that's exactly what a scalar is. And I'm going to do the same for the next one, which are compound. Now let's scroll down to compound. Let me find it. Okay. A little bit of a shorter description. Compound types can group multiple values into one type. Rust has 2 primitive compound types: tuples and arrays, or tuples. Sorry, I realise I pronounced that wrong, and I'm going to copy that again in here. As I keep saying, this code is on my GitHub. The link is in the description, so check it out if you need to check over the code or anything. So awesome. 2 different categories of data types, scalar and compound, and we're just going to work through these. So we're going to look at integers, floating point numbers, Booleans, characters, then we'll move on to compound and look at tuples and arrays. Cool. Now, before jumping in, I'm just going to make a quick comment and just say, recall, Rust is a statically typed programming language, which means it must know the types of all the variables when it gets to compile time. And this is why this video is so important and why data types are so important mentioning in Rust, because it needs to know it. Rust needs to know it before it compiles, and otherwise you'll get a whole range of errors. Kind of despite that sounding like a lot of work, Rust can usually, infer the data type if kind of left blank. I guess if you don't actually assign it yourself, then Rust can usually infer it. So that's a piece of information that I just wanted to say that's very important before we start doing a little bit of coding. Okay, so we are going to start by assigning a variable. As usual, let's let x equal, let's say 10, and we're going to assign this to a type. So as before, the way that you assign a variable to a specific type is you put a colon after the variable and then you'll assign the type. So I don't know, let's say I want an I32. So this is creating x into an I32. Now, you might get a bit confused about what I32 and U32 and everything are, and I'm just going to put a little kind of comment at the bottom. So, and I'm just going to copy this because I've copied this from the document itself. Just have a little tidy up. Okay, so this is for I and U. So I and U basically means signed and unsigned integers. So signed is an I and an unsigned is a U. Now this refers to whether it's possible for the number to be negative. So in other words, whether the number needs to have a sign with it, signed, or whether it will only ever be positive and can therefore be represented without a sign. So here we have I32, which means it's signed. But really, this only needs to be U because there's no sign on it. It's only ever going to be positive as 10. The thing is, if you then decide you are going to change x, you want I. Realistically, if you're going to be changing variables and maybe doing a bit of maths, you kind of want I just to make sure that you're not missing out on any, sign errors, I guess. So I is kind of the typical one, but that's just what I and U mean. One's signed and one's unsigned. Then the 32 part is just, it takes up 32 bits of data. So 32 takes up 32 bits of data. And I believe that's what it says on here. Yeah, takes up 32 bits of space. I'll change it to space just so then we're consistent with the document. Now, as you can see here, there are a whole range of I's. We have I8, 16, 32, 64, 128. And all this means is kind of the range of values. So if you have a, value that's, let's say this was this big. If I was to now run this file, we do cargo run, we'll get an error because the range for I, in fact, I think it might be too big. I'm just going to keep adding zeros. I'm not quite sure, which I think will be too big. So if I cargo run, we'll enter, we should get an error. Yeah. And all it says is literal out of range for I32. So if you're wondering what the ranges are, there is a little section here on the page. And it just says each signed variant can store numbers from 2 to the power n minus 1 to 2 to the power n minus 1 minus 1 inclusive, where n is the number of bits that the variant uses. So here it's saying I8 can store numbers from negative 2 to the 7. Apologies, I missed out the negative when I was explaining that. So from minus 2 to the power 7 to 2 to the power 7 minus 1. And that's basically between minus 128 and 127. So what I will do is I'll just change, we'll take this to an I8 and we'll move this to, let's say 10. And I'll just put a little comment here and we'll say I8 has the range 128 to 127. So if I change this to 127 and we try to cargo run again, I'll just, in fact, I'll clear it and then we'll do cargo run again. Just ignore the warning, but it works. The warning here again is just for the unused variable, which it doesn't matter, it just means we haven't actually used the x that we've assigned, but it works. Whereas if I was to say, okay, well, let's change this to 128, and I did cargo run, here, literal out of range for I8. So that's something that's kind of worth, I guess, bearing in mind when it comes to assigning variables with certain types, because, you may be doing some mathematical calculations and you may have two variables that are both I8s, but then when you times them together, they'll end up being like an I32, and we don't want that because Rust can't do that. It can't take two I8s and make them into an I32. It just can't do that. It has to make them into an I8 just in terms of being consistent. So that's just a bit of a side note as to the ranges of I8. But as I said, these take up a whole range of different values. So if you're interested, just check out this document and yeah, it'll explain all of the different bits and everything, and it goes into a little bit more detail. And there's also some other things you can take as well as binary and decimal and hex and all sorts of stuff like that. Okay, now something that I wanted to show you, which is a little bit of a side note, but it's consistent with what we're saying here, is I'm going to show you how you can actually find the maximum value of a given data type. So what we're going to do is we're going to say print ln, and inside there we're going to say maximum, can't spell maximum I32 is, open brackets, and in here we're just going to say std double colon I32 double colon, and we're going to say max, if I can spell max correctly. Okay, now let me run this and just check that everything's okay with the code. Cargo run. Cool. So it's printed here. Max I32 is this huge value here. Now you don't need to worry too much about what these, what this means here. I'll be explaining that later on in the course. But I just wanted to show you that you can do this, and you can change, this to I64, let's say, and rerun. Here we go. A larger number. So let's say if you start assigning a value, I want X to be within I64, but how do I know the maximum range of that? You just do what we just did, and there. So I can have that number here. We'll run it, and there should be no error because it's within range. We just have warnings, which you just need to ignore the warnings. Whereas if I was to add one value extra, let's see if it works, and we should get an error. Yep, and we says literal out of range by 64. So that's just kind of something that's kind of cool feature of Rust. A little bit of a side note, so you don't need to worry too much about that. But I'm gonna also just show you that you can also do the minimum. I believe you can also do the minimum. I'm just going to check if that's actually correct. Let's have a go. Cargo run. Yeah, you can. You can also do the minimum. Cool. So I'll just say this tells you the maximum and minimum of an I32. Of I32. So that's maximum, that's minimum. That has the range that, and we've explained the whole situation of signed versus unsigned in this section here. Okay, so now we're going to move on to the next section in, as it says here, and we're going to look at floating point types. So let's put that here, floating point types. Okay, now this is very similar to what we've done above, except they're not integers. Now, for those of you that don't know, a very quick overview is a float is essentially a number with a decimal after it, kind of e.g. 10.5. So let's just copy all of this here. We'll do the same thing. We'll just add an extra space there so we know what we're doing, and we'll just call this is integers. Let me just check that's consistent with what we've done up here. Integer types. We'll put integer types. Okay, so here let's make y, and we're going to change this to, let's do 10.5 as consistent with what we've written here. Now I8 won't work, and we know that won't work. I've just realised we're printing hello world here, we don't need to do that. Okay, I'll get rid of it there as well. So I8 won't work, and that's just because this is not an integer. If we were to get rid of I8, then Rust would automatically assign this to a float type. So the way that we assign to a float type is you just change the I to an F. And the difference here is you'll notice that that's not highlighted. And that's because here, if we scroll down to floats are either 32 or 64. And it just says it here, 32 or 64. So this cannot, F8 doesn't exist. It has to be a 32 or a 64. And notice now it is kind of formatted correctly. So again, I will just print. I'm not sure why this is indented. I'll just move that back. And we'll do the print line. And we're just going to do the same. And say, okay, well, let's print y. And yeah, cargo run, I guess. Let's clear this and cargo run it. Cool, 10.5. I believe that's what we wanted it to do. Yep, so that's floats, F32. So floats can be F32 or F64, and I think the default, if I can spell default, I cannot spell default, default is F64. So if I left this, if I got rid of this assignment of the type here, it would just automatically assume it's an F64. So that's floating point types. That's as much as you need to learn, you need to know about floating point types. The next section that we're going to move on to is what is known as Booleans. Now, if you've done a bit of coding before, you'll know that this consists of either true or false. And they're quite easy. We're just going to let, true or false, I guess we'll call it. And we're going to assign it to a bool. Now, you don't need to put Boolean, you just put bool and it does that for you. So here, we're going to say true, or you can say false. Now, what's worth noting is you don't actually need a capital. So if I was to write that, it wouldn't work. Unlike Python, you do it in lowercase. Same with false. So let true or false be this, and then again, I'll just steal this little bit of code from here. And we're going to just print out the true or false. Cool. And I'm forgetting my semicolons all over the place. I knew I'd get an error at some point, so I need to just check that. Okay, we'll save that and we'll cargo run. And cool, prints out true. Okay, so now we have covered Booleans. I'm going to move on to what are known as characters. And I'm just keeping one space between each section, which, yeah, seems intuitive for now. Okay, so characters. Now, characters, these consist of one, I guess, letter or character, because that's essentially what a character is. You have a password. Say you have a password with 5 characters. It means there's 5 letters or 5 items, I guess. I don't really know how to say a character without kind of saying it's a character, because that's just by default what it means. So the way that we define that is, let's our character equal, and we're just gonna write this. Now, it's important to note, for a character, it has to be single quotations, kind of like, I think it's bunny ears. I think that's what, when you first start learning to code when you're young, I think it's taught as bunny ears. I'm not sure if that's actually correct, but anyway. And here we're just going to assign it to the data type char. Now, whenever I see char, I always think of my best friend Charlotte, because I always call her char. So yeah, so let the character be char, and this can be changed to anything you want. So you could be a question mark, a exclamation mark, an L, anything, as long as you don't have 2. Because notice how that now you have 2 letters, doesn't work. It can be a number, it can be anything. So if I was to, I guess let's print, so steal this from above. We're going to print our character. Hopefully it should print our 2. Does indeed. Cool. Now, one thing that I wanted to show you with characters, which I think is really, really cool, is you can actually put emojis in here. And I am just going to check my little prompt on the side here. This is, I believe, I think it might be a laughing face or a smiley face. So just ignore kind of what all this means. It doesn't actually, I personally don't even know what it means. I just went to this website, which I'll put a link in the description, and you can get the code, which is down here. I don't know if that's not actually zooming in. Okay, maybe it zoomed in a bit too much. That's zoomed in way too much. My computer is lagging. Yeah, I'll wait for that to come back. So yeah, you can find the code on the side here, and it will correspond to any of these emojis. So hopefully, when I run this, and hopefully it'll print, I should get an emoji. Yes, I got an emoji out. Awesome. But yeah, just have a play around with these, see which ones you can get to work, which ones you can't. Comment down below if you get any of them to work. It's quite fun just to play around. But yeah, we've got our smiley face back. So that is characters. That's everything that I wanted to say about characters. And the next section we're going to move on to is compound types. So that's everything in scalar types. So we've looked at integers, float point numbers, Booleans and characters. Now we're on compound. So we're going to be looking at tuples and arrays. So compound types. And the first thing we're going to look at is tuples. Okay. So the first thing we're going to do is assign a tuple. So let's say let tuple 1. So let's do 22 for my, age. Let's do E for the letter of my name, and let's do false because I'm not tall. And we can actually assign each of these to their own type. So automatically, if we didn't, assign, Rust would automatically assign this to a tuple anyway, but I'm going to just assign it. So 22, we're going to have that as an I32 just by default. Then we're going to have a character, then we're going to have a Boolean. Now hopefully this will work, and I'll just do a print ln and just have tuple1. Now we've got to just check everything's just in line here. I believe it is. Hopefully no errors. We do have an error. Let's have a look. Can it be formatted with the default? Okay, let me just have a look. Print ln. Okay, unexpected add. Okay, so first of all I need to add semicolons. Now let's see what the error is. And I think, do you know what it is? I think it's because, yeah, it's the exact reason that we had before. Need to just remember to put this inside. Sometimes I quite like when errors pop up when I'm doing my videos, just because then I can actually show you, okay, well, you know, you can see hands-on what happens if you have an error and how you fix it. Cool, there we go, 10, E and false. So that is tuples. And, you know, we can actually take a tuple and we can, you know, amend it. So what I'm going to do is I'm going to make this mutable. And remember from when we were talking about mutability, that means that I can change, you know, the values in here as long as they are the same types. Okay, so I'm going to say, okay, well, let's let tuple 1, which is our tuple, keep confusing the two, and I'm just going to say dot 0. And I'm going to make that equal to 205. I don't know why 205, just the first number that came to my head. Now what this is doing is it's taking the index of our tuple, and the first index, first element, is 10. And it's going to hopefully change that to 205. And now if I was to print that, hopefully, if we get the formatting correctly, hopefully that should change it to 205. It does indeed. Awesome, look at that. So that's a way of changing, I guess we'll put here, changing, let's have a look, what would I call it? Modifying the elements. Modifying the elements. Just put need to use mut and same, I guess, data types. And that's something that you kind of need to drill in when you're doing Rust, is that you really need to remember that if you are changing an element here, so we have, you know, this, if I was to change this to hello, whoa, going a bit crazy. If I was to change this to hello, it wouldn't work, and that's because they're two different types. There you go. I expected an I32, but we found a string. So you need to really remember that when it comes to kind of coding in Rust. I believe that was kind of almost everything that I wanted to do with tuples. It was indeed. Now, just a little note that I put here, which is exactly what I just said, is this doesn't work if you've omitted the mut, so you know you need to use the mut. Cool, so it's tuples. Now we're going to be looking at arrays. Okay, so we're just going to do as what we've done, you know, in all the other kind of parts, is let, which is defining a variable. We're going to call it R for array. I could have just called this tuple, I believe. But I just called it tuple1 just in case you want to add a few more tuples. Okay, so let array, we're going to have, let's do 10, 20, 30. Okay, let's check all my semicolons are everywhere. Cool. Now, I'm just going to put a little kind of comment here and just say all the elements in this array will be I32s, just by default. So these will be by default I32s, and that's just, you know, what happens in Rust. Now, what I'm going to say is, unlike any other kind of programming language, you can't add any extra elements onto this array. I'm going to put a little sad face because, you know, we quite like being able to do that. But there's something called vectors, which allow you to do this, and we'll touch upon them later. Okay, so that's just a bit of a side note. A lot of comments here. Let's get back into doing arrays. So what you can do is, if you put mut before here, meaning it's mutable, you can change the index. So we'll just put R for array, and it's kind of similar to Python. You'll take, so this is 0 index, which is the first element, and we're just going to change it to the value that we want. So let's say 1000. Now I'm just going to run this. Hopefully we have no errors. And we don't. No errors at all. Just some warnings, which is just because we're not using all our variables in here. So that's how you kind of, I guess, what did we say before? Modifying the elements. Okay, cool. Now, again, if I was to print this out and print array, our RARR, it would print this, but with 10,000 in there. Now, if we want to kind of like explicitly define, I guess, explicitly kind of state the types in our array, we do it like this. So we're going to create a new array. I'll call it array. In fact, I'll call that array 1, call that array 2, and we'll just call it simply 1, 2, 3, 4. Yeah, 1, 2, 3, 4. Now, what's kind of worth noting in Rust is in arrays, all of the elements within an array all have to be the same data type. So if you want to change, if you want to define what data types these are, you just do your colon as usual, open brackets, kind of square brackets. You'll state the type that you want them to be. So let's say I32s. You'll do a semicolon and then you'll put 4 for the number of elements in your array. So hopefully if I cargo run this, everything should be okay. And it is. Cool. So you can change this to I64, rerun. Everything should go smoothly. And again, if you wanted just to add an extra element in here, you just have to change that to 5. So let's just check that runs. Everything's running smoothly. Cool. And something that's just a little side note, if you've used Python before, you'll know that you can literally just do something simple. I've completely forgot what it is in Python, but you can do something along the lines of, like new array, and it will create an array for you between 1 and 5. Rust doesn't do that, so I'm just going to put you don't actually get values automatically if you don't specify. So, if I was to say, okay, well, let array 3 just be an empty kind of thing of length, whatever, it doesn't work. And that's just a bit of a side note. You don't really need to know that. It's something that we'll get onto when we start doing a bit, I suppose, data analysis in Rust. But yeah, so that's just a side note. I'll just delete that for now because you don't actually really need to know that. It's not something that's too important. The kind of most important thing here to take away is that we've looked into scalar, and compound categories, data types, and we've explored the types within those. So, integers, floating point numbers, Booleans and characters, and all that stuff. So this is really important when it comes to just generally understanding data types. But that has been data types in Rust. So that has been the video today. I hope you enjoyed it. Please give the video a big thumbs up, comment down below, subscribe to the channel as well. There is also a Patreon that I've set up and a donation page if you fancy checking those out. The links will be in the description. Thank you so much for watching, and I'll see you in the next one.